In this video, we're going to talk about differentiation. So this is part 1. Before we start with the rules and how to derive a function, you need to understand one thing, which is if they ask you what is the gradient of the curve at a specific point, so at point A, you need to understand it's the same thing as asking of the gradient of the tangent to the curve at the specific point A. Now, when I say gradient of the tangent, you need to remember that it's the same thing as asking for the slope of the tangent, right? Now, the first part of differentiation, I'm going to start with deriving polynomials. To know that, as a rule, you need to know the following. If we have a function given to us, y equals x exponent n, or we might have a constant number multiplied here, then I say the derivative of this, so y prime, is n multiplied by a multiplied by x exponent n minus 1. So basically you're going to take the n down, multiply it with a, and then you subtract 1 from the exponent. So this rule is very helpful actually for us to find the derivative of a function that looks like a polynomial. Knowing this rule, if y is equal to only ax, like if we have number multiplied by x, and I want to get the derivative of that, you can directly say the derivative is equal only to the coefficient of x, which is a in this case. Also, one more rule that is very helpful, which is whenever y is equal to k, and k is a constant number here, then its derivative is equal to 0. Knowing these three rules, you can actually solve any question related to polynomials or anything that can be written as a polynomial. Now, let's do some examples and hopefully it will be clear. If I ask you y is equal to 3x squared, its derivative, again, I take the 2 down, multiplied by the 3, so I get 6. X exponent 2 minus 1, so I'm applying the rule. The n times a, x exponent n minus 1. So 2 minus 1 here will be only 1. No need to write exponent 1, so it's only 6x. Another example. If I tell you we have 2x plus 3, and what is the derivative of that? I do the derivative of the first one plus the derivative of the second one. So the derivative of 2x, it looks like ax. In this case, its derivative is only 2. Plus, the derivative of 3 is a constant number, so it's equal to 0. And my final answer here will be only 2. Now, if you know only this rule and you're finding something like this, y equals 1 over x squared. Later on, you're going to see we have a specific rule for this, and we can solve it in a different way. But so far, you know only this rule for derivation. So we need to use it to find the derivative of y, which is 1 over x squared. So as I said, it's a rule for polynomial, and as I can see, it's a quotient. So I cannot do it directly. The first step is to rewrite the y in terms of x in this way. You take x squared up, it becomes x exponent negative 2. Now this looks like x exponent n, like the rule we have on top. To find its derivative, I apply the rule. So the derivative will be, the negative 2 goes down, so it becomes minus 2, x exponent minus 2, and we need to subtract 1 from the exponent. So we get minus 2, x exponent negative 3. Now whenever we're doing derivative, we prefer not to write negative exponent, so we write it in positive exponent. To change x exponent negative 3 to positive exponent, you need to take it to the denominator. So The minus 2 stays up. I don't care about the minus 2. I'm trying to change this to positive. So we take it to the denominator, it becomes x exponent positive 3, and this will be our final answer. Another example. If y is equal to square root of x exponent 3. Let's say you're given this. Or I'm gonna make it fourth root of x cubed. You need to know how to change this to x exponent something. So no radical, no fraction so far, because we only know this rule. How do I change it? I will write x exponent. Always we take the exponent inside over the index of the root outside. So it becomes x exponent 3 over 4. And now I look at this, I have x exponent n, same as this. We apply the rule for derivative and it becomes 3 over 4. So this will go down. X exponent 3 over 4 minus 1. We need to subtract 1 from the exponent. And we simplify. 3 over 4 stays 3 over 4. X exponent 3 over 4 minus 1. You can use calculator. Or you can do it manually. It will become minus 1 over 4. Now, as I said before, we don't prefer negative exponents. So we have to take x exponent negative 1 over 4 to the denominator in order to change the exponent to positive. So 3 stays 3. Next to the 4, you're gonna write now x exponent positive 1 over 4. Now again, in derivative, we prefer to write exponents that are integers, like not fraction, not decimal. So how do I change if I want to simplify more this one? So as a note for those who didn't see previous videos, I mentioned before, if we have nth root of something exponent m, this can be written as exponent m over n. So if we have this form, m over n, we can go back to the root form. So I can see that the number down will be the index. So 1 over 4 and the exponent, I write root, and the 4 that is in the denominator, it goes as index, and we write x exponent 1 inside. Do we actually need to write exponent 1? No, so I'm gonna just remove it. So this will be my final answer. I'll do more examples. Now, if you have y equals 3 over 4 x exponent 1 over 4, this is given to you in this way, minus 1 over 5 x exponent 1 over 5 plus 3x3 or 3x cubed minus 2x plus 1 over 2. And the question, find the derivative. You do the derivative of this one alone, this one alone, this one alone, this one alone, and this one alone. So I'll apply the rule. 3 over 4 multiplied by 1 over 4. I take the 1 over 4 down. X exponent 1 over 4 minus 1 minus 1 over 5. Now I need to take this 1 over 5 down. We'll multiply by 1 over 5. X exponent 1 over 5 minus 1 plus the 3, we need to take it down and multiply to the 3. Get 3 times 3, which is 9. I'm just writing step by step. If you know how to do it in one step, that's totally fine. X exponent 3 minus 1 minus, for this rule, it looks like ax. Its derivative, as I said before, it's only a, so minus 2. And this number is a constant number, so its derivative will be 0. No need to write plus 0. Equals. Now, 3 multiplied by 1 is 3. 4 multiplied by 4 is 16. Please don't simplify these. We cannot, because both of them are in the denominator. X exponent 1 over 4 minus 1, it's negative 3 over 4, minus 1 over 5 times 1 over 5 will be 1 over 25. X exponent minus 4 over 5 plus 9 x squared minus 2. Now, if the question finds your answer with positive exponents, then what you need to do is to take this down. It becomes 16x exponent 3 over 4 minus this one is 1 on top. We take this one down to make it positive exponent, so it becomes 25x exponent 4 over 5 plus these will stay the same, 9x squared minus 2. If I want to proceed more to change to radical form or root form, the number that is in the denominator will be the index of the root, and the number on top will be the exponent of x inside the root. Same thing in the other one. So 25, I write 5 as index of the root and the x exponent 4 inside, 9x squared minus 2. Another example. Let's say we have y equals 4 over 3 x exponent 3 minus 1 over 5 x exponent 5 plus 1 over 2x. Now the derivative of this will be, I take the 3 down, so 4 over 3 times 3 x exponent 3 minus 1, which is 2, then 1 over 5 multiplied by 5 x exponent 5 minus 1, it's 4, plus the derivative of anything that is ax will be only a, so we write only 1 over 2. Now our final answer will be 3 and 3 will cancel, we get 4x squared minus 5 and 5 will cancel, you get minus 1 multiplied by x exponent 4, no need to write the 1, plus 1 over 2, and this will be our final answer. I'll do more examples. Now if you're given y to be x exponent 2 multiplied by maybe 2x minus 1, and you know only this rule so far, so as I said, we need to change anything that is not polynomial. So here we have product, so I cannot call it polynomial unless we distribute. So we're gonna distribute and we get 2x exponent 2 plus 1 here will give you 3. We have to add the exponents if we're multiplying two terms with the same base, minus x squared times 1 will be minus x squared. Knowing that y is this, we can find the derivative now. We take the 3 down, 2 times 3, 6, x exponent 3 minus 1, which is 2, minus, now this 2 goes down, and the x exponent 2 minus 1, which is 1. No need to write the 1 as I said, and this will be our answer. One more example. Sometimes you know only this rule and you're asked about the following. 3x exponent 5 plus 4x exponent 4 over 2x, and they ask you find the derivative. So first of all, I know this rule only, so I need to rewrite this. Now whenever we have numerator over one denominator like this, then you are allowed to separate. So I take this part with this part, I take this part with this part. So 3x exponent 5 over 2x plus 4x exponent 4 over 2x. Now let's simplify. I prefer to write this, the fraction, which is the coefficient of the x's, alone. So 3 over 2, you can write it alone. X exponent 5 divided by x exponent 1, we cancel all of this, and from the 5 you remove 1, it becomes 4. And you write x exponent 4. It's the same thing as writing x exponent 4 next to the 3. So it's better just to keep the x next to the coefficient, plus 4 divided by 2, you take 4 and 2 together, it will be only 2, x exponent 4 over x exponent 1, you simplify, this becomes x cubed. Now this is our y. To find the derivative, we apply the rule, so we take the 4 down, we get 3 over 2 multiplied by 4, x exponent 4 minus 1, which is 3, plus we take the 3 down, becomes 2 times 3, x exponent 3 minus 1, which is 2. Now if you can simplify or use calculator for this, divide by 2 by 2, this becomes 2 and this becomes 1. It will become 3 times 2, which is 6, x cubed plus 6 x squared. Now just one thing to remember, if they tell you simplify or find the derivative actually of x squared over 2 like this, some students they get confused about it. Just remember that this is exactly the same thing as there's 1 here next to x squared, so it's exactly the same thing as 1 over 2 alone multiplied by x squared. It's better when you're doing derivative, if you don't know how to proceed directly, write the coefficient alone and the x is next to the fraction. Now from here do the derivative, it becomes 1 over 2 times 2, we bring the 2 down, x exponent 2 minus 1, which is 1. Now the 2 and 2 will cancel, so you get 1 times x exponent 1, which is only x in this case.